Hello, my dear students. Welcome to macroeconomics classes for 11th standard. We are doing chapter number 4, that is consumers equilibrium indifference curve analysis, and today we are going to learn about indifference curve and its properties by your Jerry sir. So let's start the video. In our previous chapter, we have discussed consumers equilibrium with reference to utility analysis. But in this chapter, this is chapter number 4, in this chapter we will discuss consumers equilibrium with indifference curve analysis. It means IC analysis. So let's start our chapter. So first, indifference curve theory. What is this IC theory? It is an alternative combination of consumption of two goods which gives same level of satisfaction. Suppose that you are going to market to purchase two goods. Okay, so suppose that apple and orange. Okay, and you are purchasing some combination like that. You are taking 3 units of apples and 5 units of orange. So that combination is giving you full satisfaction. Okay, and one more combination is there. You're going to purchase now, next day you're going to purchase that one, you can say 4 combination of orange, 4 units of orange and 5 units of apples. So this combination will also giving the same level of satisfaction which is given by the earlier combination. So we can say that is an alternative combination of consumption of two goods which gives same level of satisfaction. This I will explain you more with the help of schedule and diagram. Okay, so remember, main thing, this concept is based on ordinal measurement of utility. Last chapter we have learned that chapter is based on cardinal, where we are, you can say, measuring the satisfaction in terms of numbers like 1, 2, 3 and 4. Okay, which is not practical, but this one is practical because according to this concept, utility is only ranked as high or low, or you can say more or less. Okay, so first, what is indifference curve? So it is a curve which represents about the various combination of two goods which gives the same level of satisfaction, which as I have explained you earlier, same thing, that is only called indifference curve. And this is more you can say that clear with the help of diagram. So first we learn about assumption. What are the assumptions which we have to follow in order to understand this indifference curve theory? So first assumption is coming that money income of the consumer is given and does not change. So whatever money he is having in his pocket, in our pocket, so, or you can say available money, that will remain same, it will not going to be changed. Second assumption is that the consumer spend his or her income on such goods, that type of goods which can be substituted. It means the goods should have substitution. Okay, so substituted for each other, like apple and orange. I have given example of apple and orange, so they are substituted of each other. It means these both are fruits. Okay, so the consumer preference for two goods is well defined. Whatever is preference, it should be well defined to the conditions. Okay, then more of a good always give more satisfaction. It is very important. What, when we're going to consume more quantity of one good, so it will give us what, more satisfaction. Now here it is confusing because last time we have learned about in that one law of diminishing marginal utility, when we're consuming more and more units of a good, so the satisfaction which you are getting is going to decrease. But remember, that was based on marginal utility. Okay, MU, and here we're talking about total utility. Okay, so I will explain this one also later. So this is called what, monotonic preference for a good. This is only when going to consume more of a good, so it gives more satisfaction only. Okay, last, the consumer is rational. He or she always maximize his or her satisfaction. Rational means he is intelligent, he is aware of the market conditions, so he or she always wants to maximize her or his satisfaction at any cost. This is what indifference curve theory assumptions. Now we'll talk about the schedule and diagram. So this is our schedule, or you can say table, which shows the combinations, various combination A, combination B, combination C, combination D of two goods, that is apples and oranges. Like first combination shows that combination of 1 apple and 10 oranges. When we are going to purchase 1 apple and 10 oranges, so they will get the same satisfaction which is we are getting by purchasing 2 apples and 7 oranges. And it is also equal to which satisfaction which we are getting after purchasing 3 apples and 5 oranges. And it is also equals to what, when we are going to purchase 4 apples and 4 oranges. Now these all are what, combinations. So these all will give us what, same, or you can say equal amount of satisfaction. Now the thing which we have to note here is what, just check, when we are increasing the quantity of one good, okay, apple, we are increasing the quantity of apple from 1 to 2. So what happened? It becomes 10 to 7. Okay, now pay more attention. When we increase more units of apples from 2 to 3, so here oranges become more or less from 7 to it becomes 5. When we increase from 3 to 4, so it becomes from 5 to 4. So it means when we have to increase 1 unit of one good, so that time we have to sacrifice the units of other goods. If we want to increase the units of apple, then we have to decrease the quantity of other good. Why it happens? Because we are having the equal amount of money, as we have learned under the assumptions that we are having the same amount of money. So that thing we have to, if we are, suppose that we are having 100 rupees, okay, so in that 100 rupees either I can purchase 10 apples or 10 oranges or 1 apple, or either I can purchase 7 apples or 2 apples and 7 oranges. These are combination which are showing under the given money income. Okay, this is the schedule. Now it is more clear through the diagram. So on the basis of this schedule, or you can say table, we have drawn indifference curve. As you can see here, this is y-axis, this is x-axis. On x-axis we have shown apples, and on y-axis we have shown oranges. Okay, so according to schedule, at A combination we are having what? 1 apple, 10 oranges. So apples are here, it means 1 apple, 10 oranges. So we got this point A. This is the combination A, which is showing what? 10 apples, or you can say 1 apple and 10 oranges, 1 comma 10. Okay, then we got second combination, that is what? B, at 2 apples 7 oranges, 2 apples 7 oranges. See here we have taken gap of 2, 4, 6, 8, 10, 12. So 7 will come in the between of 6 and 8, 6, 7, 8. So 7 is this one. Okay, so we get B combination where we are getting what? 2 apples and 7 oranges. Then third combination is what? C, 3 apples and 5 oranges. So 3 apples, 5 oranges, we can write 3 comma 5. And then at last D, which is 4 comma 4. So we got all our combinations A, B, C and D. Now here we are showing what? Indifference curve. Indifference curve is what? Diagrammatic presentation of indifference set. So here in this AC is A equals to B equals to C equals to D, because in terms of satisfaction, what satisfaction we are getting after purchasing 1 unit of apple and 10 units of oranges, the same satisfaction we will get after purchasing 2 units of apples and 7 units of oranges. In the same way, we will get same satisfaction from all those combinations A, B, C and D. Now we have learned here diagrammatic presentation of indifference set. That indifference curve is what? Diagrammatic presentation. This is indifference curve. It is a presentation of indifference sets. What is indifference set here? Let's learn about indifference set. Indifference set, it is a set of those combinations of two goods which offers the consumer the same level of satisfaction as we are getting here. A, B, C, D. These all are what? Indifference set. 2, 7, 3, 5. Okay, so that the consumer is indifference across any number of combinations in his indifference set. So that consumer will be confused to get which one combination, either A, B, C or D. These all are giving what? Same or equal amount of satisfaction. Okay, clear or not? So this is what? Indifference curve here. Okay, I hope it is clear. Now we'll talk about properties of indifference curve. It is a very important topic, properties of indifference curve. As we have learned about indifference curve, so it's necessary to learn about the properties also, which we have learned after observing the indifference curve. So first one is what? Slope of IC shows MRS. Now this MRS topic we have skipped this year in first chapter, but this was given in last year. Okay, so MRS is what? Marginal rate of substitution. I will explain in this one only. Let's see. As we have seen that that initially the consumer is at point A, where he is buying 5 units of good Y and 2 units of good X at this one, at this combination. Okay, when he is asked to give up some amount of Y unit, it means when he moves, or when he moves to say B combination B, where he has to purchase more unit of apple, then what happens? The oranges unit become 7. Oranges units become 7. It means decreases. Okay, and here what it becomes? It increases from 1 to 2. It becomes increase, and here it decreases from 10 to 7. So in order to increase 1 unit, he has to decrease the other unit of good. It means he has to sacrifice the other units of goods, as you can see here. So You can see he is willing to do it at the rate 2 comma 1. 2 is to 1. Sorry, not comma, but 2 is to 1. How we are getting this? By change in y upon change in x. This change means delta x, delta y upon delta x. It means how much changes came in y. As you can see here, from 5 it becomes how much? 3. So 5 minus 3, that is what? Change in y. So 5 minus 3, it comes what? 2. 5 minus 3, that's why it comes 2. And this one b, it was how much? Earlier it was 3, now it becomes 2. Earlier it was 2, now it becomes how much? 3. Okay, so in order to increase this first, 3 minus 2, how much it will come? 1 only. So what comes? 2 is to 1. It means 2 upon 1, or you can say 2 is to 1. This is only what? MRS, marginal rate of substitution. It means in order to get more unit of apples, we have to sacrifice some units of oranges. As we have sacrificed here 2 units of oranges in order to get 1 more unit of apple. This sacrifice only called what? Marginal rate of substitution, or you can say MRS, which is also the slope of IC. Okay, the slope. So slope of IC shows what? MRS. First property is over. Second, slope of IC, or you can say MRS, tends to decline, and IC is convex to the origin. Now it's saying that, as you can see here, this slope is what? Convex. This is concave. See, this is concave, and this is what? Convex. This is convex, and this is what? Concave. So if you check the slope of IC, it is what? Like this, na? Convex. So what they are saying, the slope of IC is what? Convex. And second is what? The slope of IC, or you can say MRS, tends to decline. It is decreasing. See, it's going down only. Okay, so let's understand this one property. The slope of IC tends to decline as we move along the IC from left to right. As we are moving here from left to right, from left to right. So what happens? The slope of IC is called marginal rate of substitution, as we have learned in first property, MRS. So it indicates the rate at which the consumer is willing to substitute one good for the other. So let us understand with the table. So we are studying the second property, that slope is what? Decline, and it is convex. So why this happens? Let us understand. Because of the fall of decline in MRS. Because of the fall in MRS. Let us understand this table. Combinations are given A, B, C, D, E. Combination 1 A, 1 unit of good X, 20 units of good Y, and so on are given here. So as you can see here, delta Y. So delta Y means current minus previous. So previous unit is nothing is there. So dash. Delta X is change in how much change came in good X. So current minus previous. So current is what? Nothing. Current is you can say 1 unit, and previous one is not given. So here it is also dash. So first one come dash only. Second, now current is 2 and previous is 1. Current is 15 and previous is 20. See, either we can do 15 minus 20 or 20 minus 15. Okay, so now students will say, sir, 15 minus 20 will come what? Minus 5. So just here we are ignoring minus sign. Okay, so we can 20 minus 15, 15 minus 20, how much it will come? 5 only. So change in Y, how much? 20 minus 15 or 50 minus 20, whatever you can say, 5. 2 minus 1, 1. Change in X. So 5 is to 1. Here 15 minus 12, 3. 3 minus 2, 1. 3 is to 1. 12 minus 2, 12 minus 10, 2. So change in Y, 2. And change in X, 4 minus 3, 1. Change in this one, you can say Y, 10 minus 9, 1. And change in X, 5 minus 4, 1. So 1 is to 1. Just look at this ratio. 5 is to 1, 3 is to 1, 2 is to 1, 1 is to 1. What is that? Change in Y upon change in X. And this is only called what? MRS. How we are finding MRS? By dividing change of Y by change of X. Change in Y upon change in X is called what? MRS. So 5 is to 1, then comes 3 is to 1, then it declines, 2 is to 1, then it declines, 1 is to 1. So because of the fall in MRS, the slope is also what? Convex to the origin, or you can say decline. Okay. Next property is coming, higher IC shows higher level of satisfaction. So what it means? As you can see here, we have made y-axis, x-axis, good X, good Y, and I have made this one IC1, IC2, IC3. So three combinations of IC I have made here, and this is called what? IC map, where we are showing various combinations of IC, not only one curve but many more. So that is called what? IC map. So it is called what? IC map only. Okay. Now just look at here. IC1, this is the combination. Then IC2, this is the combination. Then IC3, this blue one is the combination, as you can see here. Okay. So IC3 is at upper stage, above, all of the above. Then IC2 is in the middle and at lower IC1. So the question says that, the property says that higher AC shows higher level of satisfaction. Why? Just look at here. Now if you look at the first one, this one, suppose that this is how much, 4, okay, and this is how much, 2. So it is giving 2 comma 4. We can say A, this is B, and this combination is C. Okay, so A is giving how much, 2 comma, or you can say 4 comma 2. Okay, then check about B, combination B. So we can say here it is 5 and this one 6. This is 4 and 6. This one is giving 5 comma 5, 5 comma 4. Okay, B combination 5 comma 4. And C is given how much? C is giving us combination of 6 comma 6. Okay, now as I told you in the properties, in assumptions, that higher the you can say that satisfaction, that we are going to more consumption, so more consumption will give us more satisfaction in terms of TU, total utility. Let's check total utility here. 4 comma 2, 4 plus 2 6, 5 plus 4 9, 6 9, and 6 plus 6 12. Where are we getting the higher? 12. So where we get at this point, we are getting the higher to TU, total utility. So higher IC shows higher level of satisfaction. As you can see here, once again the proper assumptions. More of a good always gives more satisfaction. That is what? Monotonic preference, as you can see here. Okay, more of the goods gives more satisfaction. So this IC3 is the biggest here. It will give the highest level of satisfaction in compared to IC2 or IC1. If we compare IC2 and IC3, it is 9, it is 6. It is bigger than this. So here 9 is bigger than 6. Therefore IC2 will give more satisfaction than IC1. But the higher satisfaction will be given by IC3. This is the property, higher IC shows higher level of satisfaction. Now fourth property says that ICs do not cross, or you can say intersect each other. So in order to prove this property, we have first assume that there are two ICs and they are intersecting each other. We are assuming, and then we will prove that it can't intersect or can't cross. So first we have assumed that the two ICs are crossing each other. So just check here. This is Y axis, X axis, good Y, and this is good X. Okay, we have drawn a combination here. Okay, this black one showing what? Black line, IC1. This blue line showing what? IC2. Okay, the combinations of black line is what? A and B. A, B. So whatever the satisfaction we will get at A point, the same satisfaction we will get at B point also, as says by indifference curve theory. Blue line shows which combinations? A and C. So what satisfaction we will get at A point, the same satisfaction we are going to get at C point. So A equal to C according to the IC analysis. Okay, so it means A common. So what left? B and C. So whatever satisfaction we are getting by B, same satisfaction we should get by C also. So B equal to C, it should be according to this. Okay, according to this, B should be equal to C, but it is not logical. Why? Because at C, as you can see here, the consumption of good Y is the same at B and C. If we talk about Y good, so this one, just check here. This line shows what? Same combination of B and C at this point. See, B and C, same satisfaction. Okay, same satisfaction. See, consumption of good Y. So here the consumption of good Y, the consumption of good Y shows the same at B and C, same satisfaction. But if you talk about consumption of good X, just check here. B point is here and C point is here. This much difference is there. So the consumption of good X is greater than at B, as you can see here. B and C, according to consumption of good X, it is bigger. Consumption of good C is bigger in compared to B point. Okay, it can be 4, it can be 6. It is bigger. 6 is bigger than 4. So it implies that C must be offering higher level of satisfaction than B. As you can see here, just in property third, we have learned that higher the IC will give more satisfaction. IC1 is here, IC2 is here, upside. See, this much gap is there. So it is giving what? Higher satisfaction, more satisfaction. So it shows that they can't ever intersect each other. Okay, so we can say that IC do not cross or intersect each other. So here we have completed our all what indifference curve properties. Okay, and I have explained clearly indifference curve, the schedule. Okay, this is diagram, and this diagrammatic representation is only called what indifference set also. So here we have completed our first this one lecture about consumers equilibrium indifference curve. So I hope it is clear to you. Okay, thank you. At last, I just want to say be safe and God bless you all.